A robot manipulator can be divided into two sections: a body and arm assemble and a grease assemble. There are usually three axes associated with the body and arm, and either two or three axes associated with the grease. At the end of the manipulator grease is a device related to the task that must be accomplished by the robot. The device, called an end effector, is usually either a gripper for holding a work part or a tool for performing some process. The body and arm of the robot is used to position the end effector, and the robot's grease is used to orient the end effector. So now we will talk about the body and arm configuration. Given the 5 types of joints defined in the last video, there are 5 multiplied by 5 multiplied by 5, so in total 125 possible combinations of joints that could be used to design the body and arm assemble for a 3-axis manipulator. In addition, there are design variations within the individual joint types. For example, physical size of the joint and range of motion. It is somewhat remarkable, therefore, that only a few configurations are commonly available in commercial industrial robots. And these configurations are: the first, articulated robot; second, polar configuration; then the SCARA; the Cartesian coordinate robot; the Delta robot; and finally, collaborative robot. Here we have an articulated robot, also known as a jointed arm robot. It has the general configuration of a human shoulder and arm. It consists of an upright body that swivels about the base using a capital T joint. At the top of the body is a shoulder joint, as you can observe as capital R joint here, whose output link connects to an elbow joint, and this is another capital R joint, the second capital R joint. Typical applications for articulated robots are assemble, arc welding, material handling, machine care, and packaging. Now we have the Cartesian coordinate robot. Other names for this configuration include gantry robot, rectilinear robot, and XYZ robot. It consists of 3 orthogonal joints, remember, also called type capital O joints, to achieve linear motions in a 3-dimensional rectangular work space, which means that they move in a straight line on 3 axes. The 3-axis sliding joints correspond to moving the grease up, down, in, out, and back, forth. Cartesian robots are popular choice because they are highly flexible in their configurations, giving users the ability to adjust the robot speed, precision, length, and stroke size. Cartesian robots are one of the most widely used robot types for industrial applications and are often used for CNC machines and 3D printed. It is commonly used for overhead access to load and unload production machines. Here we have the polar configuration robot. This configuration consists of a sliding arm, remember the capital L joint, actuated relative to the body, which can rotate about both a vertical axis capital T joint and horizontal axis capital R joint. Polar robots or spherical robots have an arm with 2 rotary joints and a linear joint connected to the base with a rotary joint. The robot axis work together to form a polar coordinate, allowing the robot to have a spherical working envelope. Polar robots are credited as one of the first types of industrial robots to be developed. Polar robots are commonly used for decasting, injection molding, welding, and material handling. Here we have the SCARA robot. SCARA is acronym for Selective Compliant Arm for Robotic Assemble. This configuration is similar to the jointed arm robot, except that the shoulder and elbow rotational axes are vertical, which means that the arm is very rigid in the vertical direction, but compliant in the horizontal direction. This permits the robot to perform insertion tasks, for example, in vertical directions, where some side-to-side alignment may be needed to make the two parts properly. SCARA robots are generally used for assembly and palletizing, as well as for biomedical applications. The Delta robot is an unusual design, consists of 3 arms attached to an overhead base. Each arm is articulated and consists of 2 rotational joints, type R, the first of which is powered and the second is unpowered. All the arms are connected to a small platform below to which the end effector is attached. The platform and end effector can be manipulated in 3 dimensions. The Delta robot is used for high-speed movement of small objects, as in product packaging. Delta robots are typically used for quick pick and place application in the food, pharmaceutical, and electronic industries. And finally, we have the collaborative robots or cobots. This type of robots are robots that can interact directly and safely with humans in a shared workspace. There are numerous types and brands of collaborative robots on the market. Cobots are typically used for pick and place, palletizing, qualifying inspection, and servicing machines.